Hi everybody, I'm back and we are going to just have a little thing on reasoning. This video has different definitions for reasoning. The one that I want us to always focus on, sorry I'm walking around my house, is deductive. Because deductive is really the lockstep reasoning for science. And in proof. And as a math teacher, first and foremost, we're always looking for proof. Now, inductive reasoning is really good to draw conclusions on things that are difficult to mathematically prove. And there's reasoning, but it's not proof. And in math, and then subsequently in science, we're always looking for proof. And a lot of people, far too many, take abductive reasoning, which they talk about in the video a little bit, to be the same as deductive, and they're not. Not at all, because deductive is locked in. And yes, you do have to start with a truth statement, a hypothesis. We talk about this in geometry when I'm teaching it. I know at PYC Mr. Ketter does, but a truth statement that is accepted to be true. It's a postulate, which that goes into math, but that's what we need to start with science. And it is the beginning and the building blocks of our logic. So let's just read a little bit of this together, okay? So you guys can follow along. During the scientific process, deductive reasoning is used to reach a logical, true conclusion. Another type of reasoning, inductive, is also used. Often people confuse deductive reasoning with inductive reasoning and vice versa. This is what I was talking about. It is important to learn the meaning of each type so that the proper logic can be identified. And again, the end-all, be-all, capstone of logic is deductive reasoning. Inductive reasoning is not necessarily untrue at all. It's just deductive is A is true. If A leads to B and B leads to C, then A leads to C, and those are true. So let's just read a little bit more. Deductive reasoning is a basic form of valid reasoning. Deductive reasoning or deduction starts with a general statement or hypothesis and examines the possibilities to reach a specific logical conclusion. Okay? And then they talk about theorists, which I don't like the theorists too much. We're going to skip now. Deductive reasoning usually follows steps, and pretty much I would take out the word usually and just say it follows steps. Okay? There's a premise, then a second, and an inference, meaning I say this, then that happens, and then we go on. Okay? For example, coffee has caffeine. If I have caffeine, I become more awake. If I have coffee, I become more awake because I'm inserting that caffeine definition. It's like coffee equals caffeine. And if caffeine does something to me, then coffee does something to me. Sort of what it is. So here's a major. I'm gonna put my one right here. For the premise every A is B, that could be followed by the premise C is A, thusly C is B. That's the conclusion. And I don't know that Mr. Ketter does this too much in geometry at PYC, but so I'm going to infuse a lot of it as we start to do physical science because, a lot of you ask me why, and this is how we do it. Okay? Now I'm going to scroll down. Inductive reasoning is the opposite of deductive reasoning. That's true. Instead of having a thing and going somewhere, you're observing. My inductive reasoning was like I was saying in the last video of like seeing the snow, right? Which there's less snow in my neighbor's house. But here's inductive reasoning. As far as the data of the weather tables shows, it didn't get above 32 degrees since the last time I looked at my neighbor's house. So how did the snow on the roof reduce? Well, my conclusion is because I know it didn't melt. My deductive reasoning tells me it didn't melt because the temperature didn't get low enough, right? My inductive reasoning tells me that what is another option it probably blew off. Because if it's cold enough and the wind was blowing, the snow will blow away. And so it's probably still exists somewhere just in the alley, not on my neighbor's roof anymore. That's inductive reasoning. There's no way for me to objectively conclude that's what happened. But I know it didn't melt based on deductive reasoning of the data of the temperature. So it's nuanced. Inductive reasoning is the opposite of deductive reasoning. I don't know if you see my cursor here. Inductive reasoning makes broad generalizations from specific observations. So if it's not warm enough for the snow to melt, my specific observation is that the wind is blowing the snow around. So in inductive inference, here's right here where the cursor is, we go from specific to the general. So I'm making a very specific claim about my neighbor's roof, and I'm generalizing to say the wind is blowing the snow around. It's not melting. It's not going anywhere because it still sees snow in a lot of places. Yeah. And right here is this is the key. You see again? Okay. Inductive based on observations, deductive based on theory and logic and math. Frankly, math on geometric solid truths. Okay. And here we go. We can only approach but not ascertain with complete certainty. And that's the difference. Is inductive, you never have certainty, but deductive is what puts rockets on the moon. So, saying. Now, here's this example that they write about here that they put in this video. A coin pulled from the bag is a penny, and a coin is a penny. That for all the coins are pennies. You can't know that unless you exhaust all the pennies. This is flawed. It's flawed thinking. But it still is an induced logic. You're getting these samples every time, right? But it's not quantifiable. And that's why math is superior to science. Sorry, just saying. I teach both, but hashtag sorry, not sorry. And then abductive reasoning, again, is your reasoning. You're coming to conclusions, and that's important to do. But it's good to know abductive sort of leads to inductive, and inductive, hopefully through proof and through experimentation, leads to deductive. And then we have this like rock solid. This is the rock with which we can build our civilization. And we have, frankly, for many, many thousands of years. So I will stop talking. Click on this link, livescience.com, deductive and inductive, which I'll put in our assignment. And then I just have a couple of questions because I want to see if you can come up with examples that you know, okay? And fill in some blanks about things. All right. Have a great day, and I'm thinking of you. I don't know if any of you have lost someone to COVID, but I hadn't until yesterday. And it's hard, I know. So hang in there. I know a lot of people have lost a lot of people, and usually elders in our community. And we can't lose the wisdom that we need to keep. And wisdom that's like a lifetime of inductive reasoning, right? That is then subsequently told on to other generations. So hold fast. I know there's been a lot of grieving in 2020, but there's also been a lot of wonderful things. So just know that I'm thinking of you, and I hope to see you soon.